I can barely see you move, but I see you in there.
Yep,
Tell,
I'm
is,
here.
is this light too bright? It's so dull outside. I turned on the light today. Can you? I can turn on the overhead rather than the lamp. Is this
No, it's
okay?
okay.
You okay? You can see the screen fine?
I can see it.
Okay. All right, let me get Kaya here. Gotcha. Okay.
Did you get Sean Rogers?
What's that again?
Sean Rogers?
Yeah, I got you at the
Okay.
very beginning. Okay. So
Thank you.
I only see 2 so far. Do y'all see any more?
Latricia.
Oh, Latrissa, welcome. All right. We got 3 so far. Any more? I guess the guys aren't awake yet, huh? Okay. Oh, we won't go there. Okay. All right. We are now recording. Let me get this set. I forgot to do this. The slideshow set to, let's see if it'll work. There we go. Current slides. All right. Kermisha's here. Excellent. Kermisha,
Yes.
can you hear me yet?
Yes, sir.
All right. I've just got to find you in the role. I know you're in here somewhere. You're hiding, aren't you? Okay. There you are. You couldn't hide forever. Okay. Got you. Okay, we got 4. Do y'all see any others besides 4 here? Because y'all can see the blocks, I think, better than I can. I only see it when you pop up or say something. Okay. Okay. Let's start with announcements. I'm afraid I'll have to go over these every time someone new comes into the class. So you'll hear them over and over again, but thank you for being here on time. I was a minute late getting started because I got stuck in a email vortex and I couldn't get out until just about a minute or 2 before class was to start. So anyway, I guess y'all have heard that we are not returning to campus this spring. Was that a surprise to anybody?
No, sir.
Okay. And then I found out a little earlier, but they announced it formally yesterday, that we're not going to be on campus in the summer either. Did y'all hear that one? All right. Miss Owens, Donderia is here.
Yes, sir.
All right, good. Do y'all see any more than 5 pops up yet? Okay. And all the guys are still in bed. Okay. Okay. So we are having classes this summer. They will all be virtual classes like this one, or they will be online classes. There's not that many online classes. Most of them will be virtual like this class. You know, we meet at the regular time. It's just not at the regular place. And we all meet together. So they are still working on fixing the summer schedule to reflect all that. And as soon as they get it out, you can start apply or registering for summer. Some of you may have already started. I saw a few numbers before I left, and there are a few numbers out there, people that have registered. They will be in contact with you if anything about your classes have changed. But if you have not, just watch out for the registration packet, to be open, and as soon as it is, try to register for summer if you're coming in the summer. Coming meaning staying at home and coming to class. The fall, I assume we're going to be back on campus. We've submitted the schedule that way, and we hope that'll be the case. We won't know until we see how the summer goes. I hope all of you are being very careful. My wife is a infectious disease epidemiologist. She studies diseases. She is keeping close track of how the disease is progressing. She follows, what's the, goodness, that famous clinic, hyphenated name. I can't think of it now, in Philadelphia. She's been following them, that she thinks they have the best numbers. And she anticipates, oh, Zach is here. Welcome, Zach. All right. All right, the 1, 2, 3, 4, 5, 6. Anyone see more than 6 names up there? All right. Zach, I was just telling the others, I guess you probably already know too, we are not returning to class this spring, to the campus this spring. We are going to have class, okay, but it's all going to be virtual classes just like this one, unless you're in an online class, and then of course you'll continue that as normal too. But also in the summer, we will be conducting strictly virtual classes and online classes. Virtual classes will be like this one. You'll meet at the scheduled times. You'll just meet wherever you are by your computer or cell phone, and then the online classes will be as normal online. But most classes will be virtual like this one. Now they have taken down parts of the schedule to adjust it to make all the wording fit, and they'll probably actually eliminate some classes, because if we had a class scheduled both on Birmingham and on Bessemer at the same time, same class, and last summer they were okay enrollment but not overly enrolled, they're probably going to combine those two. So you'll see a fewer classes, and don't worry about what campus they're on. We're all at home. But the instructors, if they have those put back on yet, they've taken some of the instructors off while they're doing these changes. But the instructors will be pretty much as listed, unless we have some people with overloads and some people with not enough classes. We may have to adjust like that. So anyway, that will be the summer. We'll still be sitting at home in your pajamas, or however you happen to be. I have on sandals, by the way. So this is really nice. Jeans also. But anyway, I'm not following the dress code, but don't any of you tell the vice president, okay? And but we will be conducting just like we are now this summer. So once they have the summer schedule adjusted for this new change, they will put it back out there, open it up, and please, if you were planning to come this summer, please plan to continue with those plans and register. I think that things like financial aid, I think all things will run just as normal. So don't think that because the building is closed that everybody is still doing their job. Okay, so we'll be there. Any questions? I put you to sleep already. I'm sorry. Okay, you're supposed to wait until I started talking about math to go to sleep. My goodness, get up out of those beds. Okay, no, I'm just kidding. All right. If there are no questions on that kind of thing. Oh, another thing to look for. I haven't heard it mentioned yet, but they were very late for the first mini term, and they may be late for this too. But start looking for the student course evaluations. They may be very interesting this time, but they should be opening those sometime in April, and that's tomorrow as April starts. So try to be ready for that. Any questions at all? All right. Oh, here's Cordarian. Welcome. Can you hear me yet?
Yeah, I can hear you. How you doing?
Good, thanks. Good to see your name pop up, even if I can't see you, okay? I see the big C, though, okay? So does anyone see more than 2, 4, 6, 7 people listed? Because they're only letting me see one name at a time. So if I don't catch you when you pop up, I may miss you. So you've got 8. Okay, let me go through the ones I've got. I've got Zach, I've got Latrissa, I've got Cordarian, Kaya, Nadiria, Shun, and Cormisha.
Shankita.
Who?
Say her name on there.
Who was that again?
Rogers.
What?
I got Shun, Shankita. Okay. I've got Zach. Oh, my box may be there. Am I the 8th one?
No, you the ninth.
I'm the 9th one. Okay, let's see.
You
Zach.
ain't call her name when you just did the first time.
Okay. I've got Zach. I've got Latrissa. I've got Cordarian. I've got Kaya, Nadiria, Shankita. I'll say her whole name this time. And Cormisha. Oh, Christian's here. Okay. That's fine, Christian. There you are. All right. Good deal. Now I think I've got everybody. If any more popped up, do you see more than 8? 2, 4, 6, 8. Good. Okay, and Christian said she just came in. I'll try to make this quick again. I told the people who were here earlier, you're going to hear it over and over. We are not returning to campus this spring. We are going to continue the classes virtually like this. We'll have, I'm calling this a virtual classroom, just like normal, except I can't see when you fall asleep. No, I'm sorry, I didn't say that. But you can't see when I fall asleep. Okay, but we're going to stay like this the rest of the spring, and we are also doing this in the summer. There will be no on-campus classes this summer. Most of the classes will be what they're calling virtual classrooms like this one. We meet at the regular times, and we interact just like this. And then a few classes will be the regular online distance learning, so you can be, just doing it on the computer, okay? But those are limited. These are going to be the norm. All right. If there are no more questions, are there any questions for any new people who just came aboard?
Well, I have something to say.
Sure.
We got an email, about the graduation, and they wanted us to do a vote. So I voted for us to have our ceremony in July or August. They said if we are back on campus. So I guess we're not going to have one.
Okay. Now, I'm not certain about that because they were actually talking in the faculty meeting last evening that I had to go to, virtually, of course, that they are actually thinking we might be able to go back on campus second mini-term in the summer. And if we do that, then there is a possibility that we could have a graduation at the end of summer. So that is a possibility. I think that would suit a lot of people who are going off to college, especially if you're going to be out of town in the fall. That may be difficult to get back for a graduation at the end of this thing. They're going to do as much as they can to help as many ways as they can. It all depends on how the virus goes. And I was starting to say this earlier. My wife's an infectious disease epidemiologist. She has been following this pretty carefully, and she thinks this month is going to be the worst month. And so I don't, that's just her looking at the numbers as they are now. Hopefully things will start tapering off, but it's still going to be bad enough. I don't think it's a good idea to start gathering together again in May, though they may relax some things, but possibly June or July, and certainly by August, I'm hoping things will be normal. If you look at the other countries that got started before we did, that had the infections earlier, they are beginning to taper off some now. So that's sort of the good sign. The bad news is a lot of diseases like this, they sort of do decline in the hot weather because the virus doesn't last as long in the heat, but then they come back strong in the fall. We're hoping that's not going to happen.
Just sent us a message and said that the school we're gonna be virtual learning for summer is
Okay. You heard that you'd be working at home in the fall as well?
She said he's gonna be virtual learning.
Right. So I know that we'll be doing virtual classes in the summer. they haven't decided about fall. They're leaving the fall schedule alone right now until they get closer to it to see what's going to happen. But from what I understand, a lot of the community college may not be having summer classes. So if you have any friends that are at other campuses and they're not sure if they're going to have summer classes, tell them we're having them. And they're going to be virtual classes mostly, though there will be some distance ed. Now, what's that?
I said, I got a question.
Okay, sure.
I know I had missed the first 2 Zoom classes because I just didn't know how to operate Zoom.
Right.
So I just wanted to tell you that because I just didn't want you to think I just went, trying to log in. I had put down school or whatever.
Okay.
But I did want to get you that text. I completed and everything, and I wanted to give it to you. So should I just take a picture and email it, or do you want me to scan it in and email it? How would you?
Okay. Let me deal with the first one first. I realize a lot of people may have had difficulty. In fact, that very first class we had, 0 people were able to come. So I just recorded it on, just like I do in regular classes. I recorded it on Screencast-O-Matic, and it's up there on the YouTube videos. And then the last class, the one before spring break, we had decent attendance. I think we probably have more here today than we had then. Maybe not quite, but pretty close. And so that's also, I'm recording. If you'll notice the little red dot in the lower left corner, you see where I'm circling? Yeah, that indicates we're recording. I've recorded everything. I'm doing everything I can to keep this just like the in-class classes, okay? And recording them, doing everything like that. The only difference is I get to wear jeans rather than having to dress up. Okay, so that's the good news. And I get to sleep in a little longer, okay? So yeah. And then the second question, what to do with any work that you're to turn in? And that's a very good question. I planted Cordarian in the audience so he would ask that question. I still need some research papers, okay? And if you do your research paper, if you do it in Word, all you have to do is attach it to an email or attach it to a message on Blackboard and send it that way, okay? If you have something like a quiz or a test that I've sent to you and you've written on, and that's not in Word, obviously, then what you can do is, and by the way, all the quizzes and tests, and let me say this too, what I was calling quizzes before, they're now tests because they're all going to be done, just the same. So there's no reason to distinguish between them. So all that stuff in the syllabus that's talked about quizzes and tests, no, they're all tests. Your research paper counts as a test. The quizzes, all what I was calling quizzes, they're counting as tests. If you've looked in the grade book, you'll see I've changed that quiz 1 to test 1 and test 1 to test 2. And your quiz 2 will be test 3, on like this. So anything that you'll turn in to me, now actually I've had, what I'll be sending to you from now on will be in Word. What I have been sending, I've been on PDF files because my wife scanned them and sent them to you. I'm trying to transfer everything to Word because I usually do my test in WordPerfect because it's so much easier to do the equation editor and that. And in math, that's really handy to do. But I'm trying to get all those over to Word. Actually, in some of my other classes, students have typed in the answer on Word and sent it back to me in Word. That's hard to do in math, and especially show your scratch work and stuff. So what I suggest you do there is either, if you have a way to scan it and attach it to an email or to a message in Blackboard and send it back to me that way. If you don't have a scanner, if you have a smartphone and can take a picture of it, then attach that picture to an email or a message in Blackboard. So does that answer that part of the question?
Yes, sir, I'm good.
All right, good. Thanks for asking that. And I think all the people here have turned in their first quiz, which is now the first test. And several of you do have first tests still out, so get those to me as soon as you can. And also, I will be, when we finish 2.3, I will be sending you test 3, which will be what we were calling quiz 2, but that will now be test 3. It's short, sweet. It will only cover the first 3 sections of chapter 2. Were there any other questions, comments, things I can clear up? I think I saw someone else's name pop up. I now have 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that how many you're seeing, or do you see more than 9?
I have a question.
Yes. A little louder. Oh, are you on your phone now?
Yes, sir.
Okay. So you're able to see classes and go to YouTube and do all that with your phone. It's probably not great, but you can do it, right?
Yes, sir.
Right. But you're talking about how to send things in then. Is that what? Okay. That's going to be a little tougher, okay? So I take it you don't have internet availability, or you just don't have a laptop to use it?
I just don't have a laptop to use. My recent laptop just like went out on me.
Okay.
I wasn't expecting this pandemic to happen, so I just
Okay. Now, this probably isn't going to answer your question, but let me say it while I'm thinking of it. Did anybody leave anything on campus that you need? If you did, you can get on campus, but you need to call or text or email campus security first and make sure, and bring an ID and tell them that you left some equipment, something that you really need on campus and you need to get it. They will let you in, but you just stay, social distancing away. I'm taking that's not the case here. So the next thing I would suggest, if you have any friends or family members that you can perhaps borrow a laptop, and once you've taken the picture with your smartphone, then just borrow it long enough to send it and get it back to them. Now, what I would recommend, I'm married to an infectious disease epidemiologist, and she has me wipe down everything that comes into the house. In fact, she wipes it down because of my immunity situation. She will not let me pick up any deliveries or anything else. She goes out and she wipes them down with a alcohol wipe or something to make sure it's as clean as possible. Brings it in, and when we unpack groceries, she's wiped down everything that someone may have touched in the store, that kind of stuff, and we put it away. She's really careful at that. You may not need to be that diligent, but be diligent. And so wipe down their laptop, and do what you need to do, and then get it back to them. And keep your social distance as well as you can. Set it down somewhere and they come and pick it up, as long as y'all can both see that no one else is going to get it in between. Do whatever you can. Do you think something like that is possible? What's that? You doubt it? Okay. And you don't have any friends or relatives that are going to work and they might be able to send it from work? Okay. The other thing was...
Screenshot the work on your phone, write it down, take a picture, log into your email, and attach the picture to his email from your picture.
I'm not necessarily talking about just this class. It's like other classes.
Oh. Okay, now I can't answer for them, but I bet you that same thing would work for them. Can you think of why it would not? That's it.
Just recently hasn't. I don't know if it was just because of the system was flawed. I was just asking maybe if you knew something different than I did.
Okay, you'll have to talk a little louder. I'm hard of hearing, and this is going through electronics.
I was just making sure. I said, because it was different. I said, I was
Okay. Was this like an English paper or a drawing? I mean, what was the nature of it? A test, a quiz?
It was a test and a paper.
Okay. That you had scanned and sent through your smartphone. Is that right? I lost you.
Through my email.
Oh, you sent it through email through your smartphone.
Yes, sir.
And they said it didn't come out well or something like that?
Yes, sir.
Okay. Just ask them for what went wrong, what it, seemed to be the problem, and ask them if you can do it again. We're doing everything we can to make sure everyone gets this done. And there's deadlines, penalties. I've had from other classes saying, "Oh, I see this is due thus and so date." Well, Blackboard puts in that. I don't know why they put in dates, but they put in dates. In my class, just get the stuff in whenever you can. And I think that most of the other instructors are probably going to be doing that. If they're not already, please ask them if they can cut you a little slack on that, because everybody's struggling with this. You guys are better at this smartphone technology than I am. Way better, okay? So you know how to do these things better than we do. Some of us on this end, I know my old desktop computer that I had until just a couple years ago, I could not receive a JPEG file, and that's what you get sometimes when you take a picture with a cell phone. I had to forward it down the hall to Mr. West, and he would print it out for me because he had a newer computer, and then he'd bring it by to the office. So sometimes if they have an older computer, maybe they can't do the thing. See if you can find out what the problem is, and maybe find some way to do it. I can't give you any specifics, but I did put out there on the under messages something from the dean's office, academic dean's office, and it had a whole bunch of phone numbers. And those people are just standing by waiting to help with problems maybe just like that. So if you can't resolve it with your instructor, which I would say try first, then go to one of those numbers and see if someone can come up with an idea. They may actually, I don't know if they'll do this or not, they may actually say, "Oh, we can loan you a computer," that you can say. I can't say that anyone will do that, but that is a possibility. I mean, people are doing whatever they can to make this work. So I'm sorry I can't give you anything better than that, but does that give you a few things to track on?
Yes, sir.
Okay. All right. And if you continue to have problems, please let me or somebody else know. We'll do whatever we can to try to help you with it.
Yes, sir.
But thanks for bringing it up to me, because I had thought, not for people who are here, but for people I haven't seen yet, I've been wondering if they even have the ability to do this, and that really bugs me. I told the dean that yesterday, and she hadn't thought of it, and she said, "Oh, thanks for saying that." So they're working on some things to do. And I guess all y'all know this now, but I realized in some of my other classes, I had sent some of the early things, like these Zoom announcements, on as an announcement, and then I found that little icon that had the messages, and I thought that was just an icon for the announcements. So I started sending it through that because it was a little easier to do. And then I found out those are two different elements on this new Blackboard Ultra, which has big problems. Okay, so if you are in communication with any of your classmates, tell them always check the messages. That's where things are going to come now. I won't do them on announcements, because I had heard from someone else that the announcements sometimes don't go through. It seems like the messages do, but maybe they're not going through. I don't know. This Blackboard Ultra has been a big disappointment for me. I like the old one better because I'm a dinosaur. Okay. Any other questions? Comments? Okay, ready to get started on pre-calculus? Oh, I thought I heard a big cheer in the background. That's good to hear. Okay. All right, we're in Chapter 2, polynomial, and stop and ask questions anytime they come up. Okay? And by the way, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 that I see so far. Do y'all see more than 9 present? Okay. I don't know if you can see me moving this. I'm moving a black box with Cormisha's name on it to the upper right corner so it won't block the much screen. You may not see that. That may be only on my screen. But anyway, we're in Chapter 2, Polynomial and Rational Functions. We're still in the polynomial part, and we're starting today 2.3. And this is polynomial and synthetic division. Now, do y'all remember in any earlier courses doing polynomial division? They also call it long division of polynomials. Anyone remember that? Yeah. You do. Okay, great. How about synthetic division? Did y'all cover that? Okay, I figured you had seen both of these before. Before we begin, let me just review long division. Okay? And here is a long division problem I have for you. Don't pull out a calculator. I want you to do this the old way. Can everybody see what I'm writing? 12 going, say again? 12 into 619,164. Okay? I didn't just make the number up, I used something in the book to use, but you might see why if you are really paying close attention to it. You might see where I got these numbers later. How would I do this division? Now let me start with this. Addition. We usually start on the right and add to the left, right? Subtraction. We start on the right and add and subtract to the left. Multiplication. We start on the right and multiply to the left. Division's backwards, right? We start at the left and work our way to the right. Right? So how would you begin this division problem? 12 into 61. How many times will that go? 5 times. You're absolutely right. Then what's the next thing we do? Notice the first thing we did, we divided. What's the next thing we do? Multiply. 60. You're absolutely right. Okay, what's the next thing we do? Subtract. And then bring it down. Y'all have got this down, okay? 1. 12. 7. The 1, right? Okay, my writing is pretty crooked here. Okay, 12 will go into 71. You're right. Well, I think, yeah, you're right, 5 times. Okay, I wrote the wrong number down. Okay. 5 times. And that would be 60 again. I'm running out of room down here. It's going to be 11, right? Bring down the 6. Whoa, 12 will go into 116 how many times? 9 times. 9 times 12 is 108. Perfect. And then you subtract and you get 8. And bring down the 4. And 12 will go into 84. 7. Right? Okay, no, wait. I'm so glad you said 6.
Yeah.
Let's go back and say 6. No, please, let's go and say 6. What happens if we do 6? 6 times 12 is 72. But then if we subtract, what do we get? 12. And if that remainder is equal to or greater than the divisor, increase, right? I'm so glad you said that. So we increase that by 1 and make it a 7. Okay? Now that seems silly, but there is a reason for that, and hopefully you'll see later. We make that a 7, and now that goes 84 times. And look at that. It came out with no remainder. What does that mean for you? One thing it means, 12 will go into that huge number exactly that many times, which means both 12 and 51,597 are factors of this 619,164, right? Okay, so if there's 0 remainder, these things become factors. If there was a remainder, they're not a factor. The remainder, if there was one, like if there was a remainder of 5, okay, then what we could write up here is 5/12. You put the remainder over the divisor and make that a fractional form, right? But we didn't have that in this case. We had an exact answer, and that made it factors. Okay. Y'all were excellent at this, by the way. Absolutely excellent. You divide, multiply, then you subtract. Bring down, divide, multiply, subtract. Bring down, divide. Yeah, okay, y'all got it down. Okay, so let's go to the first slide here. Well, the objective slide. What we'll do is use long division like we were just doing, but this time we'll do it with polynomials to divide polynomials by other polynomials. And we'll use synthetic division, whatever that is. We haven't identified what that is yet, but it's something. I'm going to see if I can't erase it. I don't know what that little red block on my slide is. We'll use synthetic division to divide certain polynomials. There are some polynomials you can't divide using synthetic division, okay? But only when you're dividing by your divisor is a polynomial of the form x minus k. We'll get to that later, okay? And then we'll use the remainder theorem and the factor theorem, and that's why I was talking about remainders and factors earlier, because we're going to use these in long division and synthetic division, okay? So let's start with long division polynomials, which you already know how to do, whether you realize it or not. What if you're given the graph of this function? F is equal to 6x cubed minus 19x squared plus 16x minus 7, okay? And you see you have a graph here. And it looks awfully close to that graph actually intersects at 2, 0, okay? Wow. But here you have two others. That's either 1 point or 2 points where it intersects the graph there. I can't tell. It looks like 2 the way they've drawn it, but I can't tell where they are because they're between 0 and 1. Well, how do you determine what you have left? Well, if you are pretty sure that is a 0 right there, x equal 2, because x equal 2 is a 0 of f, then we know, and this is from the earlier section, that x minus 2 is a factor of f. Okay? Now, does that make sense, or is that sort of mealy-mouthed words? Does that make sense? Let me put it this way. Remember when we were factoring things, like you had a polynomial like x squared minus 3x plus 2 equals 0. Right? And if you were going to factor that, you would say, oh, that's x times x, and because the last sign is positive, that means these two signs have to be the same. The middle sign's negative, so that means they both have to be negative. That would be a 2 times 1, right? You agree with that? Did I factor that correctly? Okay? Check it. You know, x times x is x squared, minus x minus 2x is minus 3x plus 2. Yeah, that works. Well, because those are factors, we can say that either x minus 2 is equal to 0 or x minus 1 is equal to 0. Y'all have done that before, right? If two factors are equal to 0, one or the other of them has to be 0. If the product of two numbers is 0, one of those two numbers is 0. And then what do we do next? We added 2 to both sides. And that gave us x equal 2. Or add 1 to both sides, and you get x equal 1. Well, it's the same thing we got here. If x is equal to 2 is a 0, which it was here, then x minus 2 is a factor, like it was there. So that's what this statement means. Anytime you know a 0, you can just subtract it from the other side and say that's a factor. If that was x equal minus 2, subtract it from the other side, x plus 2 would be the factor. Does that make sense? Yay or nay? Okay, good. All right. So we know that x equal 2 is a 0. That makes x minus 2 a factor. So we know that f of x, this thing up here, is equal to x minus 2, that factor, times some other expression in x. Okay? How do you find that q of x? And it wasn't happenstance they chose q. What you do is divide both sides of this by x minus 2. Right? And now when you do that, and remember the f of x is that, what you're doing is x minus 2 divided into 6x cubed minus 19x squared plus 16x minus 4. That's the division you're going to do. Right? Now, I bet you if I try to do this, I'm going to run out of room like I did before. And if my memory's right, we're going to do this on the very next example. So let me go to that page so I have more room to do it. Are y'all okay with that? And guess why they called it q of x? That's going to be the quotient. The q of x is the quotient as a function of x. So let's go to the next slide. There it is. Divide that polynomial by that polynomial and use the result to factor completely. Okay? So what we're going to do is exactly what they say. X minus 2, which I had written before, divides into 6x cubed minus 19x squared plus 16x minus 4. Okay? That looks like long division, doesn't it? Now, how did we start our long division? From the left. So let's first start with x into 6x cubed. Now, if you want to break it down even smaller, look at the coefficient of x. What's the coefficient of x there? If you don't see a number, you understand it to be a 1. Exactly. So 1 will go into 6 times, right? Then x will go into x cubed how many times?
3.
No. X squared times.
Oh yeah.
Right, because when you multiply 6 times 1, you get 6. You multiply x squared by x, you get x cubed. Perfect. That's exactly what you wanted to get. But now you have to multiply the next term as well. Remember, we divide first, then we multiply, and we'll get to the next part later. So multiply this. Time out. Time out. Sorry, I meant to say something first. Before you ever do a long division problem, you better check and make sure every term is accounted for. And what you do is look at exponents. The exponent here is, whoops, I wrote it, I didn't mean to. Exponent there is 1, and the exponent here is, you don't see 1, this is 0, right? 1, 0. That's fine. Exponent here. 3, 2, 0. Blast off, right? Never mind. Okay. All right. Always make sure you've accounted for every term. I forgot to tell you that because this one already had it. Okay. So anyway, continue multiplying. 6 times minus 2 is? 6 times minus 2 is? Negative 12x squared, right? That 6x squared up there, x squared times 1 is x squared, right? Yay or nay? Remember? Yeah, okay. Now, before we subtracted at this point, but in long division, like we have here, sometimes you wind up with signed numbers, right? Now, when you subtract signed numbers, I like to do it this way because it keeps me from making as many errors. Okay? Whoa! I see W force. Who in the world is that? I thought I saw someone join the class named W force. Was that a mistake? Because I sure can't recognize who that might be. So that may have been just a random blurb there or something. Okay, so how you subtract signed numbers? Change signs and add. Remember? If you were doing minus 7 minus a negative 3, how do you do that subtraction? Leave the first number alone, negative 7, and change this to a plus, but change the sign of that, plus 3. Okay, I can't write. And that would be minus 4. Does everybody remember that? Change signs and add. So what we're going to do for the things subtracting here, change the signs, and now we add them. Because I make fewer mistakes when I add than when I subtract. That's just me. Maybe you don't have that problem. So when you add these two, those go to 0, don't they? Yeah. Okay. This goes to anybody? Negative 7 x squared. Don't forget your variable. And then what do we do next? Bring down the plus 16x. And bring down the sign with it. Okay? All right. What do we do next? We start over dividing. And there's nothing here. 1 will go into negative 7. Negative 7 times. And then x will go into x squared how many times? X times. Okay. And then what do we do next? Multiply. And negative 7 times 1 is? Negative 7. And x times x is? X squared. Perfect. But then we do the next term. Oh, Kwame's here. Welcome. Someone just got up, huh? Oh, no, I didn't say that. Okay.
No, I didn't see the access code.
Oh, I see. Yeah, they sort of hide it in there. They put so much junk there. But then finally you find the... And what you can do, I hope you found this out. My wife showed me this. I didn't figure it out. When you see that HTTP, blah, 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 if you just copy that and put it in the line at the top of your screen and have that as a thing to go to, that takes you right there.
Okay.
Command line, I guess, or whatever you call it. Yeah, or the access code, that works too. Okay, but if you'll look at that, you'll see the access code is in that HTTP thing. So it's already embedded in there. All right, so has anyone else joined the class since Kwame? So now I have 2, 3, 4, 5, 6, 7, 8, 9, 10. We reached double digits today. That's good, but I want more. Okay. Do y'all have more than 10 people showing up? See, it's not showing on my screen, I guess because I got too much junk open here. Okay. What's that? Oh, okay. I saw W force, but I didn't know who you were. That looks like Jay, is that right?
Yes, sir.
Okay. I never would have gotten W force out of that. Is that workforce? I don't know. Okay. So Jay's here. I saw the W force come up, but I couldn't figure out who it was. Has anyone else joined the class since that you haven't heard me acknowledge your name? Okay. All right. And Kaya's working out of a car or a van or something, aren't you?
Yeah, I ain't got no lights to storm, knock them out.
Yeah. My wife sent me upstairs to a bedroom because I make too much noise. She works in our office downstairs, so I know how you get away from noise. Okay.
Did you say my name is
Oh no, I didn't. I see James, and I take it it's James Webb. Is that right?
Yes, sir.
All right. Welcome to the class. Okay. Woo. All right. By the way, we're in chapter 2, polynomials and rational functions, section 2.3, polynomials and synthetic division, and we're in the long division thing, example 1, bottom of page 136. We're not making great progress today, but we have had some good discussions, and I highly recommend, if you missed the first part of the class, once I get this loaded on Blackboard, loaded on YouTube, and then moved into the playlist for Blackboard, then watch it there. And let me warn you, let me tell you what my day's like. I've got this class at 8:30. I've got a trig class at 10. I've got a linear algebra class at 11:30. And then I have a physical science class, mini-term class with a lab that goes from 1:15 until 5:45. I have to leave the lab early because I have a meeting, a online meeting or conference call or something at 4 o'clock that I'm going to be late to, but I'm going to get there as soon as I can. And then I have another meeting at 6 o'clock this evening. So when I'm going to get to upload your classes, it's going to be late this evening. So don't look for it before late this evening or tomorrow sometime. But go back and catch the stuff that we did at the first part. Okay? All right. Has anyone else joined? Okay, since James. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to an even dozen now. If you see more names up there, please let me know. All right, we're doing synthetic division, and what we do is divide first, then multiply. Not synthetic, long division. Divide first, multiply, subtract, which is change signs and add, then bring down, and then start the division over. And we did that on the second term, and now we're in the multiplication phase. We already did minus 7 times x, and for those who just came here, that blank in front of x is not a minus sign, that's just a blank, okay? That's where I was showing the 1 should go. So that would be minus 7x times x is minus 7x squared, and minus 7x times minus 2 would be what? Say again? Minus 7x, say again? Positive 14x. Don't forget the variable. Okay? And now we either subtract or change signs and add. I like to change signs and add, so I'll change that to a plus, and because I have a magic pen here, I can just change that to a minus. Okay? And then you add. This adds to 0. Of course it does. That's why we did it. This adds to be what? Positive 2x, and then you do what? Bring down the minus 4. Perfect. Okay, and then you do what? Divide again. Now here, if you remember when we divided and didn't quite divide right last time, here's what you always look for. If the degree of the remainder is equal to or greater than the degree of the divisor, keep dividing. Before when we did a long division with numbers, if the remainder was greater than the divisor, bump it up 1, okay? Same thing here. If the degree of the remainder is equal to or greater than the degree of the divisor, keep dividing. So we'll do x into 2x. How many times will that go? X into 2x. So let's go back to our coefficient here. 1 into 2 is plus 2. And x will go into x 1 time. So that's just a plus 2. So now we do what? Multiply. 2 times x is 2x, and 2 times minus 2 is? -4. Ding, ding, ding. What do we have as a remainder? 0. That means we found the other factor. This is what they called the Q of x. I call it the other factor. So the other factor is 6x squared minus 7x. Get out of there. Okay. Plus 2. Okay. Now the question before us is, can that be factored any further? We divided this, we did the first part, we got that answer. It says use the result to factor the polynomial completely. So can we factor this any further? Now, you have tools at your disposal here. You can either do trial and error, which might take a while because you have several factors for 6, only one possible factor for 2, but then you can have some fun. Okay? Or you can do the AC method. And I really don't care which one you choose. Which one would you like to do? Trial and error or AC? You choose. Anybody? Say again? AC method. Okay, do you remember what A is? A is equal to 6, B is equal to minus 7, and C is equal to 2, right? That's where we get the AC. So AC means multiply A times C, so AC is equal to 12. 6 times 2 is 12. Remember, your B is minus 7. Now what we want to do is find out with two numbers, and you can name them anything. I'm going to name them M and N. Just any two numbers, M times N. We want to find any two numbers, M times N, that multiply to be 12, but add to be minus 7. Okay? So how I like to start is first do this. When I see the minus 7 here, that tells me that, and that the product M times N is positive. That means that both of these M and N have to be negative, right? The only way you can multiply to be positive, add to be negative, if they're both negative. So don't try any positive numbers, do only negative numbers. So let's start with M equal, say, minus 1. What would the N have to be to give you 12? Negative 12, right? But then if you do minus 1 minus 12, when you add them together, that gives you minus 13. That's not equal to negative 7. Throw that one away. Okay? The next number that will go into 12 would be minus 2. What would the other number have to be to give you a product of 12? Minus 6, right? Negative to give you a positive, right? And when you add those together, minus 2 minus 6, what do you get? Negative 8. That's closer, but still no cigars, right? So let's try the next one. What's the next number that will go into 12? Negative. Negative 3 times what? Negative 4. And that gives us negative 3 minus 4 is minus 7. Ding, 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 we have a winner. Don't go any further. You've got it. But that doesn't give you your answer yet. All that tells you is how you split up your B, which is minus 7 here, to be minus 3 and minus 4. So here's what we do next. 6x squared. Don't mess with that first term. And instead of minus 7, you make that minus 3x minus 4x. And then don't mess with the plus 2. Now, isn't this the same as that? Minus 7x is the same as minus 3x minus 4x, right? Okay? Agreed? Now, what in the world could we do with that? You're trying to factor. Do you remember a technique that you use when you have an even number, 4 or more even number of terms? factor by grouping. Do you remember that? Anytime you have 4 terms, an even number of terms, I don't know how to factor those except by grouping them. So in that first group, are there any common factors? Anything that will go into both 6 and 3? 3. Anything that will go both into x squared and x? X, okay. What do you have left? Will you pull out or factor out a 3x? 3 will go into 6. 2x, perfect. 3 will go into minus 3. Minus 1 time. Right? Does that work? Okay. Now let's look at the next group. Are there any common factors between negative 4x and 2? Okay, there's certainly a 2, but I would always pull out the minus sign as well. Let's pull out a minus 2. What's left when you pull a minus 2 out of a minus 4x? A 2x. You're absolutely right, because negative 2 times 2 is negative 4. 1 times x is x. You're right. What happens if I factor a negative 2 out of positive 2? Negative 1. Yeah, because negative 2 times negative 1 is plus 2, right? Make sense? Now, take a look. You have a common factors between these two terms. 2x minus 1. So let's pull that one out. 2x minus 1, and what do you have left over? 3x minus 2. Ding, 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 you've just factored that. Okay? If you have any question about it, check it. Foil it. 2x times 3x is 6x squared. Then you have a minus 4x minus 3x is minus 7x plus 2. You got it. So it says factor the polynomial completely. Well, you knew one factor already to be x minus 2. Now you've got 2 other factors. One of them is a 2x minus 1, and the other one is a 3x minus 2. We have now factored that polynomial completely. And I didn't know how to do that before. Okay? I really did, but I mean before I learned to do this. Okay? Now, of course, okay, if it says factor completely, always factor completely. Okay? If it just says do long division, then just do long division. Okay? You just basically do what the problem asked for. If they had stopped right here, it said divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2, then we would have stopped right here and said, there's your answer. But it says, and use the result to factor completely, so then you take this answer you got and go on and do like we did and factor it completely. So yeah. And sometimes what you have left, you can't factor. And if so, just leave it. You've already got it factored completely. But this one, we wanted to check and make sure you couldn't. Now, how would you have known it wouldn't have factored? If we'd have done the MED method, the AC method like we were starting, if we got down here and this came out to be a minus 6, say, or not a minus 7, and you say, hey, it skipped minus 7, we don't have it, that means it can't factor. If you did everything right, it can't factor. So you stop there and say, that's factored completely. But if this did come up to a minus 7, which it did, okay, then we know we have the answer. I mean, we have to keep factoring. Did that answer your question?
Yes, sir.
All right, good deal. Good question, by the way. Well, let me erase all this mess that I've done here. Does anyone need it any longer? Okay. Let me erase all the ink on the slide. And let's see, now, I do want to say this. I hate doing this because it seems like I'm singling people out, but it's just because I'm worried that some people may not know how to get into the class. I know that goodness, I can't remember how she pronounced her name, Miss Childress, has been communicating with me through Blackboard, so I know she knows how to do that. Does anyone know her? Minuet, that's how you say her name. Does anyone know her personally or have her phone number or anything?
No, sir.
Okay.
No, sir.
All right. How about Kennedy Clayton? She's also, no, I'm sorry, that wasn't her. It was somebody else. She hasn't been here yet since we've done this. Tucker hasn't been here yet. Jalen, yeah, Jalen was here last time, so I know he knows how to log on. John hasn't been here yet. I'm worried about these people. Drake hasn't. If any of you can get in touch with any of these people, let them know. Keelan's been here. Tariah hasn't been here yet. Kay hasn't been here yet. That's Kay McGee. If you know how to get in touch with them, please let them know and that we're missing them. Okay.
I can get in contact with Kay and John. I got their phone numbers.
Okay. If you will, please tell them how you get on here so they'll be here on Thursday. Okay. And if
Kennedy too.
Yeah, I got Ken's number too, but she was on here last Thursday, if I'm not mistaken.
who was?
Kennedy.
Oh, she was. She
Yeah.
may have come on and I didn't catch her. You think she was here last Thursday?
Yeah, she was here.
Okay, well then I will try to change that attendance, not that it matters. So she knows how. I thought I had seen her name before. Okay, so I'll change that to a present. Okay, let me just get these others. I said Kay. Okay, Trinity's been here before. Olivia hasn't been here yet, and she hardly ever missed a class. If any of you can get in touch with her, please do that. Alexi was here last time. Cameron was here last time. Diego, I haven't seen Diego, and well, he was here the last day we were in class, but I haven't seen him since. And Jamel. So, if any of you can get in touch with any of them, please let them know how to log on.
Cameron on here now.
Oh, Cameron's here now. Good deal. Okay. Good morning, Cameron. Okay. Got you. Glad you could make it. Okay. Has anyone else come in lately? All right. All right. We just finished doing example 1 on page 136 in chapter 2, polynomial and rational functions. We were doing 2.3 polynomial and synthetic division. We're on the polynomial division, which is also called long division, and that's what we just did it. I'm going to show you how the book did it. Now, they do one thing a little differently than me, and it's okay, but here's how they do. They move everything over and put x squareds over x's and things like that. That's perfectly fine, but because I'm doing this number into that number, I like to put the result up here. That's just a difference of preference. It doesn't really matter where you put the things, okay? The book does them there, it's fine. So they did 6x cubed divided by x. That's what they're saying to do here, and that gives you 6x squared. Then you multiply 6x squared times both of these, and that's what they're saying you do here. That gives you 6x cubed minus 12x squared. Then you subtract. I like to change signs and add, because that keeps you from making as many mistakes. You notice this goes away, and when you add minus 19x squared to plus 12x squared, you get minus 7x squared. Then bring down the 16. Remember the pattern. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay, so we brought down the 16x. Now we divide again. And again, they say, well, they don't say it any. Oh, yeah, they do. Think of this as minus 7x squared divided by x. That's what they do here. That gives. Was there a question? The minus 7x, and that's where you get this one from. Okay? When you divide minus 7x squared by x, this is what I should put here. Okay? So let me take that error off so it won't be confusing. Okay. All right. So divide again. Once you divide, multiply. And that's what they do here. Minus 7x times x minus 2. That gives you minus 7x squared plus 14x. Now they say subtract. I like to say change signs and add. So that becomes a minus 14x. See, I can't erase theirs. These go to 0, and this gives you a plus 2x. Okay? Bring down the minus 4. They keep forgetting to tell you to bring down, but do it. Okay? And then you subtract, divide again. X will go into 2x, and again, think of this. That gives you a plus 2. Then you multiply 2 times that, and when you subtract, you get a 0. What does that 0 mean? That means this polynomial here multiplied by this one gives you that exactly. That means these two things are factors of this. I've drawn all over the board and you can't tell a thing now. But that's what that means. Those are factors. If this is a 0 here, that means those are factors. Okay. Now, we've divided like they said. What we haven't done is finished and said factor completely. So to factor completely, we take this quotient right here, 6x squared minus 7x plus 2, and see if we can factor it. Oh, okay. It said we can conclude from our long division, just what I said, that the divisor times the quotient equals that. The reason we can conclude that, we had a remainder of 0. So those two are factors of each other. Now, by factoring this even further, and they don't show you how. That's why we did it in gory detail. This does factor to be exactly what we did. Okay? Now you factored it completely. Okay? Any questions? Okay. Now in that example, the x minus 2 is a factor of the polynomial. And the long division process reduces the factor of 0 because it was. Okay? We thought it would be, but we weren't sure. When we saw that remainder of 0, we know it did. Often, however, long division will not produce a 0 remainder. It will produce a non-zero remainder. What that tells you is your divisor is not a factor. Okay? So keep that in mind. If that long division gives you something with a remainder other than 0, that means neither one of those are factors. Okay? So here's another one. I wish they hadn't done the whole thing. We'll do it. X plus 1 into x squared plus 3x plus 5. Let's do it here. X plus 1 into x squared plus 3x plus 5. You know, this is unnecessary, but we'll do it just for the practice. How would we do it? What you do first? Remember, with division, you start from the left. X will go into x squared. X will go into x squared how many times? 1. No, x times. X times.
Oh, x times.
Yeah, because x times x is
X.
squared, and x times 1 is x plus 1x. Okay? Now, again, I almost forgot. I did forget. Before you do a long division, make sure you account for every term. Exponent here is 1, 0. You counted for everything. Exponent here, 2, 1, 0. Blast off. You've accounted for all the terms. Make sure that happens. If not, do not do long division this way. I'll show you how to do that later. Okay? So what do we do now? After we divided and multiplied, you... What's the next step? Subtract. Okay? And I like to change signs to add. So I'll change this plus to a minus and change that plus to a minus. I've got the magic pen. I can do it. Now I add. Okay? These add to 0. What do those two add to? 2x. And then you bring down the plus 5. And then you divide. X will go into 2x how many times? 2 times. 2 times x is 2x, and 2 times 1 is 2. Okay, when you go to subtract now, you see you have, I'll go on and do that subtraction. I can do it because they're both plus signs. That's going to give you a remainder of 3. Uh-oh, SpaghettiOs. That means that these two are not factors of that polynomial. You knew that already, probably. So how would you write this answer? You could say what is written here, or you could write this remainder plus 3 over the divisor, x plus 1. That's another way you could write that answer. Remember when you did long division before, I don't know if you remember this way back, let's just take a number like 11 divided into 135. 11 will go into 13 one times. This will be 1125, and that would be 222, remainder 3. You could say that is 3/11ths, right? Remember when you did that? Same thing here. You take the remainder, put it over the divisor, and write it that way. That's two different ways you can do it, okay? So let's see what they do. Exactly that. Divisor here, they got the same answer we did, x plus 2 with a remainder of 3. Okay? Now, in fractional form, here's one you can write that, just like we did. The dividend divided by the divisor, that's written over the long division line, is equal to the quotient plus the remainder over the divisor. That's what I had done up on top there. Here's another way you can write it. If you multiply both sides of the equation by this divisor, then you get just this here because that divisor goes away, but you get this times that because you multiplied them, and then that divisor goes away here plus 3. So there's the other way you can write it. You can either write it in fractional form, dividend divided by divisor is equal to quotient plus remainder over divisor, or you can write the dividend is equal to the quotient times the remainder, times the divisor, or divisor times the quotient, either one, plus the remainder. Either way you want to do it, gives it. Those illustrate the following theorem, which is called the division algorithm. Both of these are decent ways to write your answers. If you use either way, you get it fine, okay? So here's the division algorithm. If f of x, that's your function, think of that as your dividend, and d of x, that's your divisor, are both polynomials such that the d of x is not equal to 0, because guess what? You can never divide by 0, okay? And here's the requirement. This divisor has to be, the degree of divisor is less than or equal to the degree of the quote dividend, okay? Guess what? If this f of x would have been x plus 2, and your divisor was x squared plus x plus 5, if that was the case, you can't do long division because your degree of the divisor is greater than the degree of the thing. That's already in fractional form. You can't do a thing with it. Only if the degree of f, your dividend, I can't get it right, is greater than or equal to the degree of the divisor, then you can go. Then there exists a unique polynomials, q of x and r of x, such that, this is how we wrote it the second way, f of x, your dividend, is equal to your divisor times your quotient plus your remainder. Okay? Now, remember some of our remainders are just whole numbers, like 3. Okay? Well, that's still a function of x. It's just a constant function of x. Okay? But if this remainder is 0, that means the degree of r of x, okay, or the degree of r of x is less than the degree of d of x. That's the thing to talk about here. The remainder of r of x, if r of x equals 0, then that's the case. If r of x is degree less than d of x, then you could write this r of x over d of x here. Okay. They make it sort of confusing at the end. But what they're saying, if that's equal to 0, then r of x equals 0, then the d of x divides evenly into f of x, and then they become factors of f of x. Exactly what we said before. Okay. Any questions? All right. That division algorithm, as we already said, can be written this way. F of x divided by d of x, that's the division, is equal to the quotient plus the remainder over the divisor. They've said it about 3 different times now. I've said it, okay? In the divisional algorithm, the rational expression f of x over d of x is called improper. Why is it called improper? Because the degree of your f is greater than or equal to the degree here, okay? Has to be, okay, because the degree of f is greater than or equal to the degree of d. On the other hand, the rational expression has to be proper, meaning the degree of r, let me put it this way, the degree of r, I'm going to put the degree sum of r, is less than the degree of d, okay? Has to be. Otherwise, you keep dividing. All right, does that make sense? We've said it several different ways. Okay. Now, a couple of things here, and this is what I was talking about before. Before you apply the division algorithm, follow these steps. Number 1, always write the dividend, which is your function, and the divisor, the d of x, in descending powers of the variable. If they're not in standard form, you can't do it. It comes out all screwed up. Okay? Be sure you write them both. And then, if you're missing any powers of the variable, any at all, then you have to insert a 0 coefficient. And I believe we've just gone over, haven't we? Y'all have let me go out of overtime, didn't you? Isn't it past? Yeah, I'm so sorry. See, y'all are just so excited to be here. I can tell. You just were going to let me talk all day long, and you knew I had another class coming up, didn't you? All right. We didn't get far today, but we had a lot of good discussion at the beginning. Let me see if there's any homework exercises. I know you can do number 7. That is, you can find it at calcchat.com if you have difficulty with it. I think you can do number 9, and you can also go to calcchat.com for that one. And I think you can do any of the odds 11 through 23. Okay? Now 23 might be a little tougher. You may need to be careful with that one, but give it a shot if you can. Those are all at calcchat.com. 11 is at calcview as well. Now, okay, let me hold off those. Let me change that. You can do 11, 13, 15, and 17. Stop there. Stop there because the rest of them are going to do some of the things we're going to do next. So stop at 17. Those are all at calcchat.com. Okay. Are there any questions before we go? Okay. Did anyone show up that you never heard me call your name? All right. Well, I'm glad y'all could all make it. I will go on and stop the sharing right now and shut off the thing if there are no questions. What's that?
Hey, I got a question. How do I my test?
Okay. Let me go through that again. There's a couple of things. Once you finish any quiz, any test, or anything you're doing at home, including your paper, if you put it in Word format, you can just attach it to an email or to a message on Blackboard and send it to me that way. If you have a quiz, a test, or anything like that, which, by the way, go back and listen to the first part, they're all going to be tests from now on. In fact, that first quiz, I've already made it a test, okay? Your paper is going to count as a test. All that in the syllabus, they're all going to be tests now, okay? What you can do with that, probably the best answer is to either scan it or take a picture of it with a smartphone. Whichever way you do, attach that to an email, either on a smartphone or whatever, or if you have a computer, you can also do it to Blackboard on the message. Attach that to a message on Blackboard. Whichever is easier for you to do, and send it to me that way. And I never did get to answer the second part of that question. I believe that maybe it was Zach that was asking. If all else fails, mail it to me. I hate to make you take the postage to do so, but that will work too. Just like I mailed y'all some stuff, some of you that hadn't completed some things, I mailed it to you. You can mail it back. But the free stuff is attach it to an email or to a message on Blackboard. But if you can't get that to work, and Zach, you might want to do that with your that other instructor that said it couldn't read it or something like that. You may consider making a copy of it and mailing it, or if you can't have access to do a copy, just mail the thing to her or him or whoever it is. That might be another option. Now, you may not know their address. That's right. So you might want to email them and see if you can get their address to mail them something. That's another option. But y'all who receive something from me, I put my address on there. You can send it back. In fact, one person has already done that. That was Kwame, right? And I got that, and I graded it and posted it on Blackboard. All right, good questions. Any others? Did that answer yours, James?
Yes, sir.
All right, good deal. All right, we'll see you and all your friends on Thursday, right? You're going to get in touch with everybody, right? Do all you can. Okay, I'm going.
Can you turn the grayscale on Blackboard?
I have put everything on Blackboard I've received so far. Have you turned in something?
No, I'm saying like the grayscale for the average. All my stuff in, but it don't show completely average.
Okay, say that one more time.
All three of my items in, but it don't show like an overall average.
Okay, no. I do not trust Blackboard to do the averages completely. Okay, now that they're all going to count equally, that might work. But back when I was doing quizzes is one thing and tests is another, I've never trusted Blackboard to do weighting properly, so I always wait till the end of the term to do that. But now, hey, this is a math class. You should be able to take an average, right?
Yeah.
All right, yeah. Yeah, I do not trust Blackboard to do it, because you know what Blackboard did one time? I thought I could do that. It assigned you a grade. And it assigned one of the people with the top grade in the class an F, and assigned somebody with an average grade an A, and maybe even an A+. I don't know how in the world they did that. So I don't trust Blackboard to do that anymore, so I don't have them do it. They just get it wrong so many times. And I haven't figured out why. So I don't trust Blackboard. So you can do your own averaging. Just keep getting me the stuff so I can put them in, and you can average better. Okay? Any other questions? Good questions, by the way. What's that? Okay. You can send it either through email, through a message. You just sent it? Okay, I won't get to check it because I've got class starting in less than 2 minutes and a next class, so I won't see it until I finish today, and that's going to be probably sometime after 7 o'clock tonight. Okay? All right. And there's W. Force again. All right. Any other questions? All right. We will see you then on Thursday, hopefully, right? Same time, same station. All right. Bye-bye. Ending the meeting.